you doing? Yeah, help yourself. Anything over there?
How you doing? Dan. Dan. I'm Dan. Dan. Okay.
Hey, Dan.
You the speaker? Yes. Good.
I'm Gary.
Gary?
Gary, yep.
I'm sorry.
Perfect. Nah, no worries. No worries.
There's something in the media stuff that SQL no lock hash. Sure. Lock free, skipless. So are you gonna go over that? I'm not gonna let the detail in 1 hour. Okay. We can set something up. Yeah. I was very curious. Might be something I'm looking for. Yeah. I've never heard the name before. The skipless index. Skipless index. Right. Skipless is basically an in-memory tower structure. Right. That, but really it's a stack of pointers that you can perpetually just build on. You never have to reorganize it. You never have to restructure it. So that if you compare that to like a D-tree index, right? When a D-tree index is a disk-based structure, hierarchical format that has to be written out and rebuilt, which is right. And it's very disk I/O intensive. We eliminate all disk I/O. You work for the company? Okay, I didn't know whether you're a user or. No, I work for the company. Excellent. Okay, good. We'll do some intros. And I live up the street. All right. Plymouth. So not up the street. Oh, okay. Good.
Yeah. Relatively.
What are you, Ferndale?
No, Southfield.
South. Yeah, it was a beautiful day, but first time cutting the grass.
Oh, yeah. Battle.
Well, first time, I already cut mine 3 times. You must have had some. Yeah. You had the forest. I was out of town. Yeah. The back especially. Who do you work with? I'm independent. I have my own business. No electrical.
I'm hoping that the sunshine isn't going to keep too many people away.
Oh, well.
That's why we're not doing one in August.
Yeah, everybody's gone, sure.
Yeah.
All right.
Well, it'd be very personalized.
Yeah. We'll give it a couple minutes. Some
Yeah.
people show up a little late. So
No worries.
maybe we'll give it
I'm
a
here,
little
guys.
bit
I'm
of
here to support you.
All right.
All right.
I was in front of the USA, and then check on the list of what these I'm trying to do.
Frank, I'm Gary.
Hey, Gary.
Nice to meet you.
Nice to meet you. We got free dinner.
Yeah. Well, we brought the salad, so you got all the ingredients.
Salad.
Oh, no problem.
Salad guy too, so.
Trying to get something healthy, that pizza.
Right. We're thankful for that option.
I have Scotch tape. I have Gorilla tape out my car.
Gorilla tape.
Really say that might be too much.
But
Heard of Gorilla glue. I haven't heard of Gorilla tape.
when I got to fender bender when that lady slammed on her brakes because she had her dog on the way, that's what I put my fender down with.
That's why it lasted in the rain too, though.
How'd that work for you?
It's been working really well.
It's been working.
To get into the, whatchamacallit, the phone shop.
Right.
And
Wow.
I just haven't had enough time, plus I didn't want to get it worked on in March when it was still snowing, so I'm going to go next week.
What a beautiful day today.
It's about time, huh?
I know it's about time. If it stays, we'll be good.
Yeah.
We hope it stays. Right? No more nastiness. No more snow. No more ice.
Don't even mention that.
I couldn't even get my son works down the street at the 777 building over there on Eisenhower.
ProQuest or what do you work
He works for Plant Moran.
Oh, right, right.
So I was trying to get him to come. And
Yeah.
And he said, Dad, I got an
So that's the
invitation.
day.
I got an invitation to go play golf. So he blew me off.
Yeah, I can never figure out how to get people to come out. I guess it's going to be a cold day. I don't know.
I figured analytics in the cloud, that would be kind of popular, but oh well. Maybe not.
It's all about an application. You guys run on premise or in AWS?
Both.
All the above.
We got about 60% of our customers run on AWS.
We guys based out of this area?
San Francisco.
Oh, you're from San Francisco, the company is. Not you, not you guys.
No, we're both.
Michigan based. We're your local reps.
I got a buddy of mine that went to work for internet company.
Hortonworks.
Yeah.
Hadoop. Yeah. He's doing a lot of development work.
I don't know.
That's what we find is that, Hortonworks is the open source kind of big batch analytics.
You guys know it? You guys are analytics?
Well, we are hybrid. So, what does Forrester call it? Transalytics?
Oh, transalytic.
Translytical.
Translytical, Hope,
Oh.
HTAP,
Yes.
all kinds of stuff.
Leave it to Forrester.
Yeah.
New term. Yeah, new term.
And Gartner's right behind him. Yeah, right.
Hybrid transactional analytical processing.
Right.
You look familiar.
Yeah, good to do.
Oh! Right, Mom. So what do you do? What do you do? College engineering? College engineering? Right, Monaco. Yeah. Yeah, I used to work for HP many years ago.
Oh, okay.
So I work with startups.
Oh, okay, sure.
I've been an engineer, so kind of hybrid guy. I just educate myself on AWS. And
Analytics have experienced, I've recently heard that because of the delayed spring and everything's blooming all at once, that the pollen levels are maximum by comparison to
Yeah.
what people have experienced before.
I took,
My wife has, so I was wondering
Yeah.
if your experience is
I've
worse.
been in the yard the past 2 days.
Yeah.
Because I've had them off, and I just came in afterwards, so it's been, my Zyrtec is not working, my Flonase is not working. I woke up in the middle of the night. No, not yet. I might have to go back and get
My
some,
wife does that stuff.
because I might need a inhaler.
Buddy of mine's worst he's ever had.
That's
Yeah.
what they said, the
Yeah.
news said it was because of all the delay. And do you notice how the lilacs are way late? They're usually available by Mother's Day.
Right.
They're a great Mother's Day thing, but everything just bloomed all at once.
Yeah, mine just bloomed the other day too. It's like, oh my God,
But all
where'd
the
that
other
come from?
flowering trees just came out in the recent, and it's given the allergy sufferers a real.
Yeah, this guy was struggling really bad.
I still feel really cloudy, and I didn't want to take Benadryl, because Benadryl is really bad.
Hey, how you doing? Hey, all kinds of giveaways here. Help yourself. Nothing too great, but it's free.
Grab some goodies, because Gary doesn't want to.
Yeah, otherwise I gotta take it all back.
Vendors, I hate to think, we'd rather give it to the other owner.
Hey, how you doing? Good. I'm Gary. Ashu, nice to meet you. How are you?
Dale. Who do you work with?
I'm consulting at ProQuest.
ProQuest.
Okay.
Okay.
Yeah,
okay.
sure. Very good.
We'll give you an alternative to Oracle.
Yeah, sure. Good luck.
It's a lot of our customers actually migrating off of Oracle
Teradata.
They are migrating towards everything.
in a big way.
Yeah, everything's going to Postgres or something like that.
Yeah.
Mm-hmm.
And then we find Postgres won't scale over one node. So in comes MemSQL. That's one of our big marketplaces. So a lot of our customers like Sachs, the Sachs analytics guys, right? They're actually use MemSQL behind the scenes. They started with Postgres doing open source and stuff, and got to a point where they couldn't scale because they had to. Basically, their business was growing. Good thing, but how do you scale? You can only scale so big on a node, on a single node. You scale horizontal. So,
How would you differentiate from the Sandra kind of?
yeah, it's SQL. SQL. Real SQL.
There used to be a product called Bouncer. Remember that? HP bought it. They disappeared. Used to be an SQL.
Well, that's the reason HP bought them.
All these companies burned.
Yeah, that's what happened to Vertica. I mean, they haven't disappeared yet, but there's a path for software companies to die. That seems like unless they're operational monitoring.
You know, I was thinking of the other day was,
HP, but HP doesn't do a lot of.
I was thinking about Informix the other day. I'm going, oh my God,
Formix.
where did Informix go?
Still with IBM.
Progress still around? Progress.
Progress is over. source.
Are you really?
I'm a progress DB. By one of the job, I mean,
Oh,
I was forced into it.
I'm real Sybase when I first started.
No,
Yeah. Sybase.
the reason I joined is that
Now, SAP is
I
killing Sybase.
misheard in the interview. They said progress. I heard Postgres. I was like Postgres, AWS I can do. And I came in and they said like, oh, it's not Postgres, it's progress.
Progress. Oh, I thought you said Postgres.
Progress, yeah.
No, I mean I said like a lot of their systems are migrating from Oracle to Postgres. But this one project or one product which we have, that's on progress. And progress 9x. That was
I remember that one.
2004 or something.
Yeah.
We are migrating to
its own
11.7 at
4GL
least.
progress language.
Yeah.
Wow.
We are migrating now.
Showing
to
my
9x.
age. Anybody ever work with a language called Mark IV?
Yeah, I've heard of it, but that's about it.
We were at 50 years ago.
No. 15 years ago, I was with BEA
When we got Oracle.
from 2005 to 2015.
Probably.
Prior to that, I was the Java evangelist.
Were you a Sun Microsystem guy or were you an Oracle guy?
I was a BEA guy. So, WebLogic, application server.
Yeah, I remember that.
It's still there.
Yeah, it's still WebLogic, it's still the application server in the middle tier. Right. But they all come from different worlds. Should we just maybe start while we're waiting?
Oh, it's only 6:32. She said to give him that 10 or a few minutes.
A little more time.
Yeah. Oh, traffic's horrid.
Okay.
Where did you guys come in from? Are you right here in town?
I live in Plymouth.
I live in the
area. It took me an hour to get here, but I got here from Toronto.
Oh,
36-minute flight
wow.
from Toronto Pearson to Detroit Metro, and then it was like 25 minutes here from Detroit Metro.
Sailing.
So it was like boom, boom. I was
Yeah.
here.
I came from Southfield. Took me an hour and a half.
Wow, that sounds about right.
Yeah.
South an hour and a half. That's right.
So with all the construction right now,
Oh, it's nuts.
crazy.
That's crazy. This time of day, it's
Right.
It's crazy.
Right.
I would take 8 Mile Road.
You know, it might as well.
It might have worked. Yeah.
Might as well.
Well,
I would take Pontiac Trail across the top.
Yeah. Yeah.
It's a nice
Well, I take Pontiac
drive.
Trail.
It is,
I take Pontiac Trail. That's where I did this.
Right.
Pontiac
That's
Trail.
beautiful.
Yeah, it gets jammed up. Pontiac Trail and 8 Mile is jammed up.
Yeah.
I bet.
Pontiac Trail does because all the curves, right? Around, it has to curve around all the little lakes.
Yep,
So
up there by
yeah.
Pontiac.
It's really
Yeah,
pretty,
yeah,
but it's
it is pretty, yeah.
it gets two-lane jam.
Going north in the morning, going south in the morning, and north at night.
Right.
I always
Right.
feel bad for the poor bastards on M14 or Ford Road. That never seems like a good,
No,
you know,
it's not.
never works out well.
If you're trying to get on 275 from 14, doesn't matter what time of day, you can hit it back up.
Well, then
It's a mile
14 to 23, and even at 14 all the way through, you know, there at Main Street, that whole connector.
Yeah, that one too.
But I love this
Yeah,
area.
that is a bigger encouragement for me to attend all the meetups around Albert.
Yeah.
So that while drive back is
You let the
easier.
traffic.
Yeah, right. Hey, you got dinner? You know, come on.
I live in Novi, Michigan, so
Alright.
preferred route is at 14 and 275 or
Right.
That could be rough.
So I live off of Beck Road in Plymouth. So if you're in Novi, you're probably not far off Beck.
I'm at the back, 1 mile from back, at 12 mile and back.
12 and back. Alright. That's what's the restaurant I like to go to? Lena's. Lena's for breakfast. It's 12 mile north of 12 mile. And back. It's actually in a little like a 5-story building, not too much different than this. Little back black front. You would never think there's like a restaurant in there, but it's the best place for breakfast.
My wife's family was from Plymouth, so I didn't know about that.
Yeah, well, that's actually for Novi.
Oh, okay.
It's 12
Okay,
mile. 12 mile and back. Yeah. My family's up in Novi, so my sister-in-law is disabled. So we spend all our time going up back road.
Yeah, yeah.
We basically take care of her on the weekends, and her husband gets to go do all the, because he takes care of her through the week. why we know all the restaurants and everything around there. Just half of it, I should say half, but every Saturday of our life is.
It's surprising. I was just playing a gig for a wedding, and it was this place in Lansing, and they didn't have an elevator.
Really?
They had some wheel people that were coming in, and they couldn't go up to the, see the rest of it.
Isn't that a code violation these
Well,
days?
I wonder. Yeah. I don't know.
If it's an older building, maybe it's
Very old.
It's grandfathered.
Yeah. Pretty tough to retrofit an old building like that.
Before we start, can we just maybe do a little intros? Just so we know
Yeah, or
what
you want to,
it is? Sure.
Amy, you want to wait for 10 minutes, or what do you want to do? I mean, no sense holding you guys up. You're here on time.
Does everybody mind waiting another 5 minutes?
I'm okay waiting 5 minutes.
All right, 5 minutes. Get more pizza and salad, and
Yeah.
we've got a whole bunch of giveaways here. I don't know if there's any that's worthwhile or not, but it's free. The books are good. Books are
Yeah,
real
some
good.
good books.
And then there's you can download those too. Those are digitally available.
Yeah, I just got one page, so I'll take one.
Yeah, and then they're digitally available, so there it shows you how to download them from the web.
Little headphones.
It's fun to read without batteries sometimes.
Oh, an actual book.
Yeah.
What's this print stuff?
Somebody told me it's when I was really young. Well, I mean, it's from college. Biological organizational knowledge base.
There you go.
I like the old.
Haven't heard of that one. Yeah, if we run out of any in there, I got more, so.
Maybe China. It's kind of cute. I like it.
Yeah? Take a couple of them. There's plenty there.
See, no, I don't like those. There was one we have. I was complaining. because-
Yeah,
because Gary
those
didn't-
fold open to a bag. They're pretty
the
cool.
bag, yeah. So when you're at a conference, right? Those are giveaways at conferences.
Yeah.
So you can then throw all your crap into the bag. My wife's a teacher. And, she has little kids, and they are like 20 of those bags in their classroom, and they play shopping with MemSQL bags.
Trade shows. It's much crap.
Swag. Swag. Tchotchkes.
When the kids were young, you get that stuff, and it's $5.
Yeah.
Like,
Yeah, yeah.
what are you?
Well, it's like the T-shirts. I'm like, there's not too many adults going to wear this, but take it for your kids. Take it home for your
I got
kids.
so many T-shirts.
Yeah.
I got so many T-shirts. I finally got rid of my EMC shirts about a couple years ago. I've had them like 18 years. Even my son had.
So one thing that's really interesting about EMC runs their Customer 360 app on MemSQL. But EMC owns some of the most active databases.
Oh, really?
Yeah, so EMC owns Pivotal.
Yes.
Pivotal owns Gem. Not which one.
Didn't we have a talk
Green
back from Pivotal?
Green Plum, yeah.
Yeah.
He was just here. The guy
Yeah,
from
but,
last month. Yeah.
but they use MemSQL for their own internal business. So we'll talk about those kind of things. But we have a bit of, it's just a unique thing that we do that a lot of people can't. So,
There's quite a few people that watch this on the video from comfort
Once
of
it's
their
recorded,
computers.
yeah.
And not only that, but live. You can
Yeah.
watch it live too. So
cool.
But they won't get any giveaways. And they
Mm-hmm.
won't get any
They won't get the food.
salad.
Have you guys done any other meetups or?
We do a lot of meetups. We did one up in Minnesota. Well, not so much around here, but I'm doing one in Atlanta in 2 weeks.
Oh, wow.
We did one in Boston last week.
Talking to Columbus about doing one here in a couple weeks.
That's why.
Have you guys done like the West Michigan cloud group? There's one out there. I noticed.
Nope.
I didn't know that.
Yeah,
There is
seems
one?
to be one. Is that, what is it? I was looking at it. The West Michigan cloud meetup or something like that. I think they do a little bit of everything. All the time.
There's actually a lot of stuff happening in Grand Rapids.
Grand Rapids, I
Yeah.
always like Grand Rapids.
Yeah, you got a lot of industry out
I
there.
think so.
I always like West
Oh,
Michigan.
sure.
So West Michigan Cloud.
Yeah.
I think so. I looked up and it was quite better.
quite clean because we were just
Where would you
between
find most?
terms.
Yeah.
Where would all the AWS?
So the seniors are gone. When's the that's been
Yeah,
quite
yeah.
some.
No, it's
That one seems to be
yeah.
more
Okay.
This one
general.
was on,
What about Detroit?
April 30th.
I've never been to
Yeah,
It's
I
brand
remember
new.
that.
Yeah.
I was talking to a few
Or May
people,
1st, I
it
guess,
seems to
this
be
year.
small
But
people wanna get
yeah,
out
so
of
we're
the
into the
city
spring
and-
term
They
now.
have
So
a-
we're
Did you
in
go
the
to the
first
one
of
a
the
couple
first
weeks
of
ago?
the
You
year.
did. They had
So there's
AWS
five.
Connect.
It's pretty cool.
Connect.
Right.
Yeah, their offices are brand new
Okay.
now
But
downtown
that
in
means that you're not
Jefferson there.
competing with,
They had a pretty good
you know,
turnout too. They probably had
5,000
50
posters
people.
to
Yeah,
fill
really?
up
Yeah,
that.
it was a lunchtime deal.
Anyway, so
When are we
we'll-
doing-
Oh, it was an hour and a half, just the
March?
next couple.
Waiting to hear from the guy.
They got another one coming?
Well, yeah, another one coming or just.
Yeah,
There's
and
the
so they do it at lunch
Sterling-
because, like you said, everyone wants to get out of the city.
Sterling Windmill.
Okay.
So they did a lunch thing,
Yeah.
and
Pretty well
But
attended.
the
He's
AWS
with,
one,
he's with Duo.
it's run with
Oh,
by
okay.
AWS. It's an AWS thing.
Yeah.
It's an AWS office there
He's
down on
sometimes
Jefferson.
get a hold
That was
of,
funny, I know
so-
John Dixie spoke to you before.
He might have done a tech talk,
Okay,
like a Duo tech talk.
All right.
because I have a guy I used to work with, one of our office guys, Mike DeLoy. He's very, very, very happy there.
Yeah, well, he does.
And if you ask a question, you're gonna get.
I don't think
Yeah.
they're
He's
gonna
the
fight
one
for
who
questions.
organized the
Well,
skate
wasn't
park,
it interesting
too.
when that was tossed around, it knocked somebody's
Yeah.
computer?
Yeah,
Oh, no.
my friend Chris.
Actually, we're
Yeah,
gonna do.
you
I'm gonna
get,
knock your
drink,
Coke
yeah.
onto
Right,
your.
I think,
It's-
yeah,
So it's
yeah.
Curtis, Steve, and I forgot what the other guy's name was.
I worked in that building for like a decade when it was afterwards bookstore.
Oh, yeah?
So afterwards, in fact, my boss Steve, he still owns the building, but he is, anyway, long story short, I love that building, I have a lot of memories there, I worked there all the way through school and
Oh,
grad
yeah,
school.
you gotta be in the
Yeah.
queue.
So I'm glad
Yeah.
I've been in that space.
He said he'll
They're
move
doing
it, but the
really
more
well.
I move, the
Wide
more
land,
the
right.
strong
Yeah, Grand Rapids is killing it, my daughter went to school over there and was a huge fan.
The one in Detroit's really cool, too.
I've never been there.
I need to get to that one. Well, I guess we can get started.
You guys want to get started? Yeah.
Just wanna
start
do some
with us.
intros before we turn it
Yeah,
over.
since we got a small group, let's keep it real casual and intimate and questions and have a
What
little
do you-
conversation.
You wanna start off?
Yeah, so my name's Gary Morrison, and I'm the Midwest sales leader for MemSQL. I'm located here in Detroit, and UM grad, so it's nice to get up into Ann Arbor and that. But I'm responsible with working with our customers here in the Midwest, so we've got customers like Kellogg's and CMS Energy, and then some people in Minnesota that are customers. And we're just opening our practice here in the Midwest and getting things going. And anyways, we get into the introduction, I'll talk a little bit more about it. But my background is I was with Oracle for 6 years in their real-time data replication space. Before that, I was with IBM for 10 years as well. So
What are you most famous for?
just being a good-looking guy.
So I have to tell you what he's most famous for.
Yeah.
In MemSQL, he is the only ex-pro athlete. So he
Play
played.
football?
No, I played hockey. I played here at U of M,
Oh, yeah.
and then I played pro with Philadelphia for
Wow.
3 years.
Wow.
So-
Now
so look him
I'm,
up.
but that was
He's
before
got a
we were
great
making
fight
money.
scene on YouTube.
That was before the guys were making money, so that's why I'm schlepping software these days.
I like the fight scene on YouTube. That you're-
Yeah, really.
there's a little
Yeah, I
sports
guess
announcer
you
on the
did
top.
dig
And
it up.
Morrison's.
Yeah.
But anyway, so this is Dale Deloy. Dale
Yeah.
is our Senior Director of Sales Engineering for the East Coast, so he covers a wide range, and he's gonna do our technical presentation today.
So for us, the East Coast starts at the Mississippi River and goes east. So not quite the East Coast, the eastern half of the
Yeah,
U.S.
the eastern half of the
and,
US,
yeah.
east
Eastern
and
half
west.
of North America.
Change from W to K for the radio stations and TV stations.
Yeah. So we
That's
actually.
about right.
No, it is.
Yeah,
It's-
yes.
Is that right?
I'm from Minneapolis, so I know
Yeah.
that.
Okay.
Yeah,
That's
so,
where they change.
right, we cover Minneapolis and those states that touch the Mississippi,
Right,
right, are still in the east, and everything else we count west.
yeah.
So,
Iowa,
we have some K
Nebraska,
stations.
Bad for me.
Yeah.
But Dale's gonna do our technical presentation tonight, and, we appreciate you coming. So, I mean, we have such a small group here, I don't know if you guys know each other and wanna do a little brief introduction, or,
Yeah.
So my name's Tom, I'm Tom Knox, I work at the College of Engineering at U of M, I'm with the IT provider there, Kane, I'm the manager of web applications.
great.
Okay.
I'm Frank Monaco, I work for a company called Geospatial. I'm just here to learn about, more about AWS and MemSQL tonight.
I'm Chuck Anderson. I work for a local quant shop. I do a combination of data science and statistics for predictive analytics.
Cool.
Do a little bit in the cloud, moving there.
My name is Ashu. I'm working as a consultant at ProQuest.
my boss. And so I'm AWS certified person, and looking for data migration, cloud migration kind of projects.
Okay, great.
So hi, I'm Jay Nagandi. I'm at ProQuest, Director of Technology, and responsible for our teams that, ProQuest does we deal with a lot of data at scale. We have large archives of documents that users access online. And we have an extensive presence on AWS right now. So we have a combination of apps that are running inside of AWS and others that are in co-located data centers. But we use AWS very heavily.
Great. Dan?
I'm Dan Diebold, and I'm an electrical engineer, and I'm pretty much interested in any type of analytics, machine learning, big data applications. I've been following Chuck around for 3 years.
I'm following him. So.
Actually, I did arrive first.
Yeah.
Myself, Srinivas. I'm a DevOps engineer at 4C here at
Okay, 4C results.
Yeah, I work with
Yeah.
4C results. We are on AWS, and pretty much I go around for all the meetups which talks about AWS and ops things and analytics and stuff. Yeah.
Great, appreciate it. We got all kinds of giveaways over there, so help yourself to any of the stuff that's there. There's books and T-shirts and coats and everything, and if we run out, we got more in that, and then the food and that tonight. So hey, we really appreciate the opportunity to sponsor tonight. We're gonna, primary focus of the presentation is analytics in the cloud. So I'm gonna familiarize just a little bit with MemSQL, but certainly this isn't a sales presentation, but so we want to get into the technical part of the session, which Dale is going to present. We're going to talk about a number of different architectures that our customers are using in the cloud, and get as deep into that aspect of working in the cloud and doing analytics in the cloud as you want to go. And then Dale's also going to do a live demo. You know how those go, but we're going to do our best shot at it. But actually bring together a cluster very quickly.
You just cursed me.
Yeah, right. No. Kiss of death. Yeah. Bring together a cluster very quickly using EC2 instances and upload some data from S3 buckets. Bring it into the database and then run some real brief analytics against it. So kind of show you a little bit how to do that and how we do it. And of course we're going to use MemSQL as the database, but so walk through a live demo with that. And because we got such a small group today, I mean, just keep some interaction going and ask questions whenever you want to, and just have a nice conversation while everybody's getting a bite to eat and have a real informative session in that. A little bit about MemSQL real quick. So we are we just finished our Series D funding. We're located in Silicon Valley, right downtown San Francisco. We were incorporated in 2011. So our first product came to the table probably 2011, 2012 timeframe. And we are the next generation of relational database, and I'll get into that in a little bit in a second, but we're perfect for the cloud, and we are a certified AWS partner, part of the APN network. And if you look at our cloud base, we've probably got about 150 customers now. Probably 60% of those are in the cloud, and 60% of what's in the cloud is on AWS. So we've certainly got a large presence there. And ourselves as an organization, we do a lot with AWS. I think somebody told me that, hey, we write about a $60,000 or $70,000 check a month to AWS for all our development and everything else we're doing with them. So for a small company, that's a lot. And that. So our company, basically, we're built for the internet. We're built for internet scale and internet speed. The guys that founded our company were ex-Facebook and ex-SQL Server engineers. They met at Facebook, and kind of the concept was, hey, let's take the best of Facebook, let's take the best of SQL Server, put it together, and I think we'll have a pretty good database to take to market, and that's exactly what they did. And in a short period of time, we've amassed, probably 150 customers. This is just a brief snapshot of some of them. We're going to go into detail into some of these as to the architecture they're using, what they're doing with analytics in the cloud and how they're doing it. So we can share some of that with you. But we're all about real time. We're all about speed. We're all about data at scale. and making that available to you. And as you think about those kind of things, you think about the legacy architectures that are out there, the Oracles, the IBMs, the Teradatas of the world. Think about trying to scale those systems. Think about trying to add new users, concurrent users to those systems. Not only does it get exceptionally difficult, it gets exceptionally expensive. And so this is where new technology like MemSQL is coming into play, where we give you the ability to handle that scale, handle that speed, but to do it at significantly lower cost. And so that's some of the things that we'll talk with you about very briefly today. But those are some of the biggest issues that I think companies in the enterprise space are looking at today. Is we've got so much data out there coming off of sensors, coming off of tablets, coming off of smartphones, everything that's out there. We need to be able to get that into our organization. We need to be able to use it to our benefit. How do we get it into our organization without creating huge bottlenecks? And can we even get it into our organization with the systems that we have today? And so that's holding a lot of companies back. The ability to run fast queries. I mean, too many times, we hear from people, hey, my dashboard's hanging, my reports are going to take 24 hours to run. I mean, it's slowing down the pace of business and how people do things today. And then lastly is, the citizen population is becoming much more savvy around data. I mean, think about in your own organizations, how many users now, the ones, surprising ones even know high-level programming like R and Python and Scala and some of these other things. They want access to the data, and they want it now. I was at a customer's the other day, and the IT director was just sitting there saying, hey, people are just telling me to get out of the way. Get IT out of the way, give me access to my data, and let me go, and I'll do what I want to it. So how do we solve these kind of issues? And that's exactly what MemSQL is designed to do. So we are a distributed relational database. We're distributed, think about Facebook. We are on commodity, shared nothing hardware. So when you go to scale up our system, if you want to scale up Teradata, IBM, Oracle, what do? You buy more cores, you build a bigger box. Even those top out. With us, we take exactly the opposite approach. Instead of scaling up, we scale out. You add more pizza boxes and scale out that way. What that enables us to do now is to set up massively parallel pipelines to ingest data very, very rapidly into the organization. So the more data I want to bring in, the more pizza boxes I have out there, allows me to scale my systems that much faster. The other thing that we do is that we are an in-memory first database, but we also leverage disk. We have a row store, in-memory row store database, so when we ingest the data in, we bring it first into there, and then we roll that over to disk for more historical, colder types of data. So we're able to deliver huge amounts of data into the system by our massively parallel pipelines, but we're also able to allow you to query that data as it comes into the system. We're not streaming it in, we do persist it to memory or to disk, but we're using things like skip list indexing and hashing. We're able to allow you to immediately query that data and get it to your end users that need it. For the more, yes?
Did you mention the term rows store?
Row store.
What is that?
Traditional relational databases are a row store, where a row.
Oh, I
Yeah,
thought you said
rows and
rows.
columns.
Rows and
No,
columns.
rows.
Okay.
Yeah.
Yeah.
He's got it.
Versus a column store stored this way,
Yeah,
row
yeah,
store
yeah, yeah.
stored this way. Yeah.
Well, once we get some beer in here, and then we'll really start getting things going.
He slurs more, watch out. All new terms.
So we leverage both. So we're hybrid in a number of ways, but we're hybrid in one, and then we use both in memory and disk-based column store. So for the more historical data, you can put that out there, and then as we'll talk a little bit about our pricing model, but the way we price is much different than from the other vendors in that we only charge you for the data that you've got in memory. So you could have 10 terabytes of data out there. It might compress down to say 2 terabytes is Dale's favorite analogy, because we got excellent compression, probably 80–90% compression. So the 10 terabytes is going to compress down to 2. We might keep a quarter of that in memory, so you got 500 gigs in memory. what you pay in a licensing cost for our system is 500 gigs. You don't pay on the 10 terabytes. You know, that's quite a bit different than what other people are charging for it. So not only are we able to deliver data at scale, at speed, but we're able to deliver it significantly cheaper as well. So we're cloud-based, you know, obviously on AWS, but we can also be on-prem. So we have a lot of our customers who have regulatory issues. We were at Kellogg's the other day where you know, they deal with the evil empire out in Arkansas, Walmart. Walmart won't let them put anything on AWS. So they run our system not only in the cloud, but on AWS, but they also need to have an on-prem system as well to meet their customer needs. And that. So there's another area where we're hybrid. We run both in the cloud and on-prem. And the last part is, you know, is the data types that we use. So relational. Accessing our data, you don't need to know any high-level programming languages. You know, you certainly can use Python, R, Scala, whatever it might be, but if you know SQL, ANSI SQL, you can access all the data in our system. You probably know 80% of what you need to know to get data out of our system just by knowing SQL. So that's what the thing that people like about our system is that it's fast, it's scalable, and it's easy access. And when you put all those things together, it's a significantly lower TCO than other systems that are available out there. So that's, you know, I kind of covered a little bit about this. The last part, these are some of the use cases, and Dale's going to go into these, some of these in detail and from a technical level, but just at a really high level. Kellogg's uses us, you know, more of a business intelligence way. What they're actually doing is found that with their traditional data warehousing, between ETLing, what they're doing is they're compiling data from sensors in the field. When they deliver cornflakes to the grocery store, they can't chalk that up as revenue until they've delivered to the store. So the guy in the truck scans it, okay, this pallet's been delivered, now that flows back to Battle Creek, and then it can book that as revenue. But what they were finding was that with their traditional data warehouse, it was taking them anywhere from 20 to 24 hours in order to get all those things to flow through their system. They do their ETL against it, then they get into the data warehouse, then they do their analytics, and then they can book it. Well, on a quarter end or a year end, they're losing out on a ton of revenue because they can't book it fast enough. Now they use MemSQL under the covers there. They bring the data directly into MemSQL from their sensors, from their IoT information, and they cut what was taking them 24 hours down to about 20 minutes. So they're actually able to impact their bottom line by using MemSQL and that. CMS in Jackson, what they're doing is they have smart meters now. You know, they got about 2.5 million smart meters in Michigan now, and they are ingesting all that data. So that's all information that's coming off of all the meters. They're also bringing in stuff from their turbines and their wind turbines, their generators, their transformers. They're using it a couple different ways. They used to bring it into a PyHistorian. I don't know if any of you are familiar with the PyHistorian databases. It's been around for a while. It's for, you know, a lot of the utility field for a lot of the fancy data formats. It's kind of like Hadoop. You know, it's very easy to get data in. It's a great storage medium, but getting data out is, you know, very difficult. So they weren't able to report fast enough on that data. They wanted to use it for predictive maintenance, to be able to find out when, you know, when's a turbine going bad, when's a generator going bad, because those are customer sat issues. You know, if we get home and find out we got no power because the transformer down the street blew up, we're not very happy, especially today with the air conditioning cooking. So what they do is they're booking all this information into MemSQL, system okay, but what they're looking for is system not okay. And now they can use predictive analytics against that to get a technician into the field before that transformer blows or before it goes out, and get to it before it impacts their customer base. So they're using it with a lot of IoT information. They're also using machine learning with MemSQL as well. Because with machine learning, it takes volumes, petabytes and petabytes of data to be able to score your algorithms, to be able to monitor the algorithms, you know, keep them performing the way you want them to perform. What they're using it for is fraud detection. So they're able to run petabytes of information through and find out radical shifts in the amount of electric usage for different businesses or 4 different homes. And they've been able to save find millions of dollars worth of fraud by being able to do the fast analytics against it, be able to adjust the information quicker, and to do the machine language against it. Macy's, again, tracking their inventory completely through their supply chain, getting faster turnarounds on their analytics so they can actually get aged inventory out quicker, not have to do as much discounting on it, cut the usage there. Uber's a great one. What they use this for, when you launch your Uber app, you get a little map with a little car on it, tells you how long it's going to take to get there for it. Well, if you got a big event going on, like a football game here or something, it all of a sudden kicks in surge pricing. Your $5 ride just went to $25. Another customer sat issue, right? Nobody's happy when they get surge pricing. So with MemSQL under the covers, what they're able to do is, because we can handle geospatial data as well as structured and semi-structured data, they're able to do something called geofencing and actually look at a specific geography, see what the demand is, and then flood the market with cars in order to keep surge pricing from kicking in. And they're able to do that in real time. So keep their customer satisfaction high and be able to meet their demand in real time as they go forward. Pandora, Comcast, those are all branding use cases. Comcast is actually a little big brother-ish, but what they're doing is actually tracking every click off your set-top box to who's watching the Super Bowl, okay, who's not watching the Super Bowl. If they're not watching the Super Bowl, what are they watching? So that helps them be able to manage their customer demand. What kind of shows are people watching? What kind of shows are you watching? What are you binge watching? What kind of ads should we be pushing out to our customers? And able to do that on real time. They deliver all this to dashboards that the executives look at, and they're making immediate decisions in real time based on all that information coming off our set-top boxes. It's a little scary, but for a company, hey, this is a way to drive ad revenue. It's a way to optimize their environment and to do it before it impacts their customer base. So there's just some of the use cases. Dale's going to dive in very deep on the technical standpoint of that. Lastly, this is kind of a busy chart, but gives you an idea on our architecture. The underlying theme here is that we are built on the MySQL wire protocol. So MySQL, open source database. We are compatible with any tool out in the marketplace that is compatible with MySQL or who puts the MySQL wire protocol into place.
I think it's Mario now that's open source.
Yeah, MariaDB, yeah.
Mario is the extension now.
Is it?
I think, isn't it?
Yeah,
that
they're both
MySQL
open source, right? But Maria is still moving forward and enhancing and tuning, and so we actually prefer the Maria database drivers over the MySQL because they're faster. But they're both still open source.
Yeah.
So
right, and then the idea is now we're compliant with everybody. There's nothing proprietary about this, so that we can plug into any of your message buses, MQ, TIBCO, and Kafka, Kinesis.
Oh, Kafka.
Yeah. Streaming, we're able to. We have pipelines built for that, so you can ingest data through that. Spark, any of the open source we're able to leverage as well. And then we can run, that helps us run on the cloud too, so that we can run in AWS instances, bare metal, whatever it might be, and then plug in on the back end to any of your data visualization tools. So whether it's Cognos, MicroStrategy, ClickView, Spotfire, any of the ones out there that are MySQL compliant, we're going to be very, very compatible with. So that's kind of an underlying theme that we're very open architecture and very easy to work with.
I have a quick question. What you're talking about streaming and having historical data reminds me of Kafka and Spark in what's unfortunately called the Lambda architecture, which is nothing to do with AWS Lambda, but it's the Lambda architecture. But in order to do that, you have to build your own cluster and all that other stuff, and it much more overhead, or fussing with. And this happens automatically, essentially.
No, you still have to build a cluster, and that's what Dale's going to show you tonight, is building a cluster.
You put in a CloudFormation template, and it builds it for you. You got to tell it how big you want it.
It's faster than doing it the other way.
And it is dramatically faster and much simpler.
Right.
Right, so many of our customers leverage us as the Lambda architecture. So you look at Comcast, right, and everything that they do is actually streaming into Hadoop.
Right.
But, right, they're actually streaming into Hadoop via Kafka, but we're also streaming
And then
directly.
persisting in.
Report
Yeah.
into MemSQL. All real-time analytics is happening in MemSQL.
Mhm.
Historical stuff still comes out of Hadoop, right? They basically fork that out.
That's the landmark,
Yeah.
Thanks.
So that's enough of the sales pitch. I'll turn it over to the technician here and let, get into the bits and bytes.
I thought that was a technical pitch.
Actually, I just wanted to ask
You do all the work. Now you gotta work on the demo.
So I think we're done.
Okay.
All right, let's see if I can. All right. So first, I should have closed this off first. My email. You guys don't want to read my email. Okay, so I'm going to talk about horizontal architectures, how we're put together, how people use us, and again, it's more the technical side of how things are being put together, and why MemSQL in AWS. Because I always look at it and say, well, AWS, you got all the RDS stuff, right? Why are people using MemSQL instead of all the RDS pieces? Right? Anyone have a guess?
Easier?
Easier? No, we're actually harder. We're actually harder. RDS is really simple, right? And we have kind of our own little RDS thing, but we're harder. But still, there's a really good reason.
Scale, cost.
Scale, cost, very good. Yep. And so we'll talk about those things in detail, right? Scale from concurrency. Right? Has anyone tried to do Redshift with any above, like, say, 15 concurrent queries at the same time? Right. Slows way down, right? So we have a basically scale out structure to allow you to do really massive concurrency, thousands of concurrent users and thousands of concurrent databases, right, to really scale. The other thing is around cost is with RDS, when you look at an application set, how many copies of the data do you end up with in AWS?
Three.
Probably 2 or 3, right? At least, right? MemSQL consolidates those in, right? Because we are hybrid transactional analytical, right? So you're able to run a transactional app where you normally have like an RDS, I forget which one they call it, but they have basically a MySQL bundled, they have a Postgres bundled in those RDS. You pick one of those that are application kind of transactional, and then you end up taking that data and copying it in and loading it into Redshift in order to do analytics. We combine that together and create one database, one infrastructure, cut your AWS costs in half by being able to really do it all together in one place. So those are just some things that, before we get in here, I wanted to, how many of you guys are actually doing stuff with AWS and those types of tools? Yeah, okay. Those are some things, we offer an alternative to leveraging those tools.
So you have any performance comparison charts against, say, Cassandra or DynamoDB or?
Mm-hmm. Yes. Now, what we normally do is we'll talk about our customers' experiences, right? Because benchmarks can be structured in a way so that we always win, right? Or they always win, right? Benchmarks are hard to make real, right? Because what do you put, how many things are you going to load out there to make things happen, right? So we would like to talk about our customers and why they use us. So from a Redshift perspective, right? We had many customers migrate away from Redshift. We ended up being between 4 and 6x faster on aggregation queries, right? We had many customers migrate off of Postgres once they got large enough to where they were overwhelming the memory of a single box. So we ended up being up to 10x faster than Postgres at large scale. And the same happens with SQL Server, right? We have a lot of customers that are SQL Server, or they live with SQL Server, right? But it's single node, single box, right? And once you kind of overwhelm the amount of memory that you can really put into a single box, the performance tanks, right? We drive out performance at a very linear structure to deliver performance that you need in a very predictable manner.
Comparison against Cassandra?
Yeah, so Cassandra we look at as basically can't do the queries we do. And Cassandra basically stops, right? Because have you ever done a join with Cassandra? You got to write it, right? You got to write 2 different queries and join them yourself with your code, right? That's not SQL. That's right. So what many of our customers will do is, they'll have these huge, wide Cassandra tables because that's how you have to put it together. Wow. So it's really massive resource issues, right? And how much data you have to have. So we are able to ingest data as fast, sometimes faster, sometimes they're faster, depending on the size of the tables and the data, right? But we're very fast from an ingestion perspective with Cassandra. But as soon as you turn on analytics on Cassandra, we are a yes, and they fail.
Just
right?
because of the complexity of data extraction?
No, because the complexity of what our customers want to do with SQL, right? Not one table, but they want to bring in third-party data, right? And so now if I'm Comcast, right, and I want to see what's really going on, and I'm getting data feeds from NBC and CBS and HBO and all those kind of things, and I also see what my viewership is in real time, and I can see all those merged, joined together, right, into the same, right, it's being able to join data together, right, and use traditional SQL tools and not have to code. That's the big difference with Cassandra. Yeah. But we compete a lot with Cassandra.
So if I have to summarize the strengths and weaknesses for this, so you are much better than traditional RDBMS because its memory is parallelized and the multi-node and all that. So
That's
your
right.
writes must be much faster, you can ingest much faster.
Correct.
Cassandra writes is
streaming data in to MemSQL, you're actually streaming data into the in-memory row store. Right? And we're flushing the disk behind the scenes, even though it's in memory, but we're flushing that data out. But you can be streaming this data into a defined column store structure. You cheat by putting it in the row store instead, and when you hit 100,000 rows in a partition within the database, you flush it down behind the scenes. So we're cheating, right? So if you had just inserted a row, right, it is still uncompressed, fully in memory, right, out there. And so you don't see that as a user. It's what the database does for you behind the scenes. So when you run a query against that table, it queries both the row store segment and all of the column store segments together. So it basically, I'd say we cheat. We use this row store in-memory structure and then flush every 100,000 rows. Does that make sense?
Well, sort of. It still sounds like some kind of magic happening under the covers.
And of course
So
there's
it has to be, right?
So
Otherwise,
the magic is that your query set is those 100,000 rows, your data will immediately available.
Right.
Right.
But you'll be even faster if you query against the 72 billion rows, right? Because you're going to be querying a dictionary and not the data itself. And the dictionary keeps the min and max value of every segment file in that dictionary. And so if you're querying for, let's say, a date range between, the 1st and 31st of this month, right? It's only going to ever get to that data of that 72 billion rows. It's only going to look at that one once. Nothing else gets touched because the dictionary is what's used to actually drive.
What's in the dictionary? Because you can do more elaborate queries such as, statistical, but I don't know.
Yeah,
You
so
have
it's
all the summary statistics in the dictionary.
yes. So there's a series of summary statistics in the dictionary, but you have. So here's where some of the magic. I'll give you. There's some guts behind the magic, right? So when you define a table, you have to tell it the order in which you prioritize the sort structure for the data and how it's stored. So if I'm CMS Energy, mostly I want to look at the last 3 months, but I've got plans to have 7 years. What's the first item you think is most important in their sort? Date. Yeah, it's the date, time date. Yeah, exactly. Right. So that's everything is sorted by the date. So once in a while, they got somebody who wants to look at things that are 7. They don't have 7 years in there yet. They've only had 3 years. But when they look at something that's 3 years old, right, they'll have to go back and look at that data, right? But usually they're going after the first 3 months or the last 3 months and looking at what's going on and the trends there. So date is number one, and then it's maybe like region and transformer and meter ID, and then those are the things that are kind of tracked. And then in a separate table, it's customer and those type of things that tie to that structure.
So if you're running this super fast ingest that goes into memory initially, right? So does it mean that from the perspective of the client that is writing data into your database, that let's say when I'm doing a write and I expect a commit, I expect the data to be secure and which I'm interpreting as in memory as not necessarily being secure yet. So is that just slower in the sense that as a writer it's going to take a little bit more time for the
that's a great question.
Commit to get completed?
It's a great question, right? So we allow you to set different commit levels based on what you need as an organization. So the default is commit when you've written to one node in memory. How safe is that? Not safe at all, right? But if you're doing this for high-level analytics and not as the system of record, that's great. It's fine. It's extremely fast. It's streaming in. Yes. You don't care if you miss, this.
And so if I've got the IoT sort of application where I'm getting a gazillion readings from somewhere, then any individual reading may not be that important.
Exactly. So that's the first level. So we allow you to do that, and that's massive streaming, right? That our customers do that with, because they don't care if you miss a few, right? And even though we are going into the row store in memory, it's still perpetually flushed behind the scenes.
Sure. Yeah.
Right, but it's flushed in a batch structure. So we're always, I don't know, a couple hundred milliseconds behind from when we commit to when it's actually pushed to disk in that base structure and how it's put together. So that's number one. Number two is we basically have 2 copies of the data, right? And what we do is we put, because we're just built on commodity nodes, we'll put those commodity nodes, well, in AWS, we put them in different availability groups, or availability zones, sorry, zones. Right? Got to get the right cloud with the right term, sorry. Different availability zones, right? And we have what's called availability groups. So you would assign the nodes that you want, so we basically make sure that the data that you have is split across availability zones in an AWS. And in that scenario, a lot of our customers will choose that for commit. So when it's committed to memory in 2 copies, so and we do basically a synchronous commit then, with a 2-phase commit on synchronous structures, they'll use that as the commit. Right? So that's another way, and then you're much more secure because now I've got 2 copies in 2 different availability zones.
Yeah.
And then number 3 is I want to wait till it's already pushed all the way to disk. Right? And then I get Oracle speeds. Right? Because we're waiting on I/O.
Got it.
And if I put that into, it depends on my IOPS, right? I'm going to set my
Yeah.
IOPS in AWS and
So all of your storage is local? You configure a bunch of EC2 instances and then all of the storage is local?
no.
Okay.
Because what happens with the base local storage in AWS when a node crashes? The local storage.
Yeah.
Poof, completely gone.
Disappears.
We're a database, right? We can't allow poof, right? Think about it, right? The data goes away, and I mean it doesn't match, doesn't work. So we have to be in EBS,
Okay.
right? Because EBS, you're persisted, you live through a crash, right? So we want our data. If something happens in AWS, a node crashes in AWS, we're living through that, right? Our high availability solution will say, oh, we're going to switch over to this, make sure this other node is running, right? And we're going to send your queries all over to that other node.
Yeah.
And so we'll keep going with transactions and keep running. You may get a transaction or 2 that will fail at the point of that crash, simply because they're in process within the node. So you always have to do a little bit of retry in your app. Or the client may see that you had an issue. Yeah.
Well, we're talking, Matt, one other question. I see SQL, and I wonder if it's not only SQL is that?
Sure.
Okay.
And that's
The
actually
schema
what-
limitations.
This is great questions, guys, but.
Okay.
Well,
I don't want to interrupt your
my
flow.
My demo,
Yeah.
right? I'll tell you what my demo is. It's Kafka, and I got a Kafka server, and I just wrote a little Java app. Remember, I came from BEA, so it's my world. I wrote a little Java app that's just generating JSON, right? So JSON documents coming in Kafka. We ingest those, so we have a native Kafka connector within MemSQL to do ingestion. We ingest that JSON. We have JSON as a first-class citizen within the database. So now you've got the ability to basically do all this IoT stuff, right? That's coming in a standardized JSON format. We then have the ability to query and calculate columns out of that JSON to drive performance. Right, so what we'll do is actually ingest through our pipelines into MemSQL. We'll have the JSON document, we'll store the JSON raw. We could just leave it at that because we can query basically everything in JSON raw, but we always want to put a few indexes on it. And then in order to put some indexes on it, we'll do a calculated column out of the JSON, persist that as an attribute within the database, and then put a skipless index on it. So we'll do extremely fast JSON ingest and querying for that.
Well, I meant, what about adding additional columns on the fly? That's
Sure.
part of the, so that's the schema limitation.
Right, I could do that within JSON if I wanted to do that, or I can just do alter table,
Okay.
add column. Right, but then I have a schema. I do alter table, add column, I'm set with a schema.
Right, that's what I.
A lot of our customers will do JSON, right?
And that's the attribute of Mongo, is like you can
That's
add
right.
a, you know,
Yeah.
so you can just.
So a
add
lot of our
column.
financial systems customers went with Mongo
Mhm.
to start off, right? And they've migrated from Mongo to MemSQL because of the analytical processing that Mongo doesn't do very well.
Right.
Yeah. So we add the analytics onto the ingestion together. Okay.
Thanks.
All right. Here are some of our use cases. All right, what are the common traits of these 4 things? All right. And what does MemSQL do for you? And this is a key one, right? The ability to perform analytics without aggregation. Right? This is why many of our customers choose MemSQL. I don't have to aggregate. I can just ingest raw data, and because of the way we're storing that raw data and operating that raw data, I don't have to pre-run aggregates. I'm able to deliver fast query results to a dashboard on raw data. So now I've got this operational set of data, and I don't have to extract to a data warehouse. I don't have to build out a data mart. Right? I'm consolidating, reducing the number of copies of the data that you have to have. Ingest and query performance. Right? The ability to ingest, again, we cheat, right? We do everything into memory, allow you to set your commit rates based on what you need to do, and then go from there. Consolidation, right? Many stores to one. Right? The ability to take my transactional store, my analytical store, my data warehouse, and consolidate them into fewer and fewer components. Being able to do high data volumes with low latency. I'll throw out a few names here, right? So Akamai. Anyone know who Akamai is? Content Data Network, right? Akamai uses us. If you guys use them, right, you get bills from Akamai, right? It's MemSQL. Why do they use MemSQL? Because they have servers all over the world that are creating events. We ingest 10 million events a second from the content data network of Akamai into MemSQL. Ingesting 10 million events per second.
That's kind of a lot, isn't it?
That's a second. Yeah. Now it's 60 servers. It's massively parallelized. Right? It's 2,000 cores in these 60. I mean, it's not on my demo. It's not on my laptop, right? It takes power and guts to make those things happen. Those are the types of things that we're doing. So Akamai is one, right? We're working with a division of Verizon that does weblog ingestion, right? At 2.75 million transactions per second. And from when that weblog happens to when it is up and available is less than 20 seconds through the total stream. And it's basically real-time analytics. Right? Banks are using this, right? And Gary talked about Comcast being a little bit scary. Our number one customer, our largest customer, is the FBI, the U.S. federal government. Right? Basically ingesting locations and tracking it geospatially, and they've geofenced basically all the key areas in the world where they are watching and tracking. Okay. So, very cool ways of.
And that's operating in the secure realm of AWS then?
That's exactly right. That is in the AWS DC
Right.
secure cloud. Yep. So some very cool things. And all that leads to customer sat and cost reduction all at the same time. So here's a few customers, right? Comcast, we talked about Uber, Cisco. Cisco is actually one of our biggest partners. They resell us within some of their appliances. So if you're buying some of the small business services from Cisco, I don't remember what they all are right now. We are actually embedded in those. Cisco also sells a cloud DVR product. Cloud DVR, basically, if you look at what Comcast does, they sell that to all the other cable providers. So if you're doing Charter or whoever your WOW or whatever, and doing a cloud DVR, it's most likely us through Cisco. Verizon, we kind of talked about. Samsung, your smart TV. You're doing smart TV, right? They're also tracking every click on your smart TV and using MemSQL really to manage their network.
Can I ask a question? In the case of Akamai, what was that number again per second?
10 million.
10 million, okay, so that's 10 million per second, and however many seconds there are in a day, that's a tremendous amount of data. I know you said you ingested the memory, but is it filtered, aggregated, purged?
It is.
Saved to disk?
Right. So they are aggregating every 4 hours,
Okay,
right? Saving the aggregates and purging.
okay,
They're not saving it all.
okay. I'm just thinking that's just a tremendous amount of.
It's huge. Yeah. But it's compressed, and it's, we ingest into memory and then we compress and things like that. So, they get, CMS is getting like 94% compression because it's a meter, right? And the data's the same over and over and over again, right? Now, Akamai, they get about 80% compression when they put their data. So it's a little bit different, but some of the use cases here for IoT, the ability to basically take data through Spark, Kafka, an enterprise service bus. So we're working with TIBCO and BEA WebLogic and IBM MQ stuff to be able to. They all have JDBC adapters, and we're basically taking messages from them and writing them in either through JDBC with the ESBs, right, or through a direct Kafka and Spark connector that it's our technology. Gives you the traditional. You've got an ODS, a data warehouse, a data lake, all these copies of the data, and you put your structure up on top of it. What we do is basically get rid of those 3 copies of the data and put it all into one, into MemSQL. You see in our structure here are 3 things that we do: stream data in to a row store, push it to a column store. That's what the 3 things in MemSQL are all about. Tells you the architecture and how we're storing data behind the scenes. CMS use case, right? This was something that they went from queries that are taking 22 hours to getting the query results set in seconds across these 72 terabytes of data. A lot of competition there. HANA, right? SAP HANA, right? One of the key things that's different in HANA is when you're using HANA, it's basically all in memory, right? And their in memory is the column store instead of pushing that down to disk. So we basically we're 10x cheaper because of the architecture and the way we were able to store on cheap disk versus having everything in memory. So I'm skipping through this because we kind of great questions, but we running out of time. Their legacy architecture, Pi Historian, SAP, ERP, Oracle, and we basically replaced that.
So even within a company, they have data silos that restrict them. That I just saw from that. Yeah.
Absolutely.
Yeah.
And that's
yeah.
And if I were to have a startup today, right, I don't have to. I could do without data silos, right? It's today, but based on historical capabilities over time, right? You end up with my Oracle, my SQL Server, my Pi Historian, it's just life over 100 years. And
that makes me think one of the most expensive costs is getting the data in the cloud then, right? When you got the historical stuff. So okay.
Yep. So I'm going to jump here to some of our customers, but what I'm going to talk about a little bit is getting the data into the cloud, because we have a hybrid solution set, right? And we work with the MySQL wire protocol. And so there are change data capture tools, Golden Gate, Attunity, stream sets, all these different change data capture tools. So what we do as a base practice for our customers is basically set up CDC. So you'd be looking at your current Oracle database, and it has all its stored procedures and all that kind of stuff. So it's really hard to migrate away from, but you want to start getting closer and closer to real-time analytics. We put a CDC tool onto that Oracle, and we will pipe that up into AWS, into MemSQL, right, directly. Now, you may need a week or two when it starts off to get your terabytes built out, right, and to get it all going up there, right? But that's a huge piece. But then we're perpetually syncing that, right, usually with very low latency, a second or two, depending on your network bandwidth connection to AWS. So it's CDC into an AWS environment. So that allows us to do that movement, but then synchronize the two. Right? And then it gives you the opportunity to gradually migrate into AWS for that type of scenario. Let's see. Traditional data warehousing, we're accelerating traditional data warehouses. Right? You see Kafka and Spark are ways that we're doing that by streaming data in more real time, but CDC is a key component of what we do. Right? We use other tool sets like Tungsten, open source CDC, works great from Oracle to MemSQL if you need to be open source. That's another thing with MemSQL. We are not an open source product, but all of our connectors and everything built around us is open source. So anything you need to do to build things in and out, to get data in and out, is open source and available to build and modify. So here's Dell, Customer 360. They basically, we got 5x performance over SAP HANA, but also, quite frankly, because of our ability to ingest the data and have it in near real time from 20 different sources, all into one database, it gave them a Customer 360 advantage there. I'll just skip through this. Macy's, Pandora, Akamai, we kind of talked a lot about these. Citibank is doing anti-money laundering types of analytics, right, on MemSQL, because they can run very fast queries, right, and join data. Right? They can join their anti-money laundering. They're actually joining their employees' information to their customers' information to see if there's any collusion going on. Right? And so that's why, with Cassandra, you just can't do that type of thing. Right? You got to be able to join these things together in a dynamic fashion. Akamai enhanced billing, we already talked about quite a bit. And then Hadoop and Hadoop augmentation. This is the Lambda architecture that you asked questions on earlier. So here's one that actually, Curriculum Associates. You guys leverage Curriculum Associates in your?
It's not my area, but entirely possible.
And another one of our large customers is College Board.
Okay.
Right, so College Board testing and all that, right? That's all MemSQL behind the scenes. In the educational world, I only say that because an education guy here, right? So just a couple of things, right? PwC, they are doing basically AI-based audits on their customers. Right? They have a MemSQL cluster with 2,000 databases in it. They used to have 2,000 SQL Server instances.
Wow.
We consolidated that. Talk about cost savings, right? There's work, right? It didn't just happen overnight, right? They have to change code and. Right?
Do they do that because they worry about database lockup, or why do you have to have so many different databases?
Every customer, right, is a secured, Sachs-based customer. Right? You can't share the data from General Motors to Ford, right? If that makes sense, right?
Who's the customer again?
PwC, PricewaterhouseCoopers.
Oh, okay, yeah, sure.
Right.
That makes sense. Sorry.
Massive audit, right? And so they're basically doing. They used to have, the auditors come in and actually have paper and do all that stuff. It's all automated with AI, basically going through and looking at and doing very fast audits with basically doing a dump of your ERP into a MemSQL environment. So anyway, very interesting. Another key one, things like Goldman, General Electric. General Electric is ERP consolidation. You know, they have tons of divisions, right? So what our customer in General Electric is the finance division, because basically they consolidate ERP, 25 different ERPs, right, across the company into one view for finance and management. So they use MemSQL to close the books. Now they haven't been doing very well, so I don't know, maybe we're not doing that well. But anyway, just some different things.
Goldman Sachs, they just booked some good trading revenue, so.
Yeah. So their solution is, so you imagine streaming in market data and comparing it against portfolios and having your high wealth customers in a portal.
There's a whole nother competing database going on right now, which is distributed, which is blockchain, and everybody's investigating into that. So I don't know if that's a competitor for you or not.
No, I think we look at blockchain as being a not so much a total technology, but a methodology that MemSQL fits on top of.
Okay.
Right? So blockchain is really, how do you speed up blockchain? You put MemSQL underneath it. That's
Interesting.
yeah, some of the things that we're looking at. Yeah. So I'm going to, again, we went through a lot of great conversation and questions.
That's what you asked us to do. I feel bad that we're.
No, this is
pushing
good.
late.
Because we went through, in the questions, we went through those things. We talked about Lambda, we talked about the different scenarios. So great questions. I don't have to bore you with PowerPoint. So I'm going to just go into AWS and show you, here's my EC2 Management Console. I brought up 3 nodes here, Deloy pipelines and the Kafka server. Okay, these are just very small M4 XLs, so 4 cores, 16 gig of RAM, small little nodes in AWS. Yep, sorry, it's small. Should have increased.
My eyes are going.
All right, so now this is the MemSQL operational dashboard that allows you to see what's going on in your database. So we actually have a lot of deeper analytics, but this is kind of the high level structure that you would look at.
So you can just zoom in a little bit on that page so we can see. On the right hand, you've got the little.
No, that one.
No, on top, through the browser.
Oh, you want me to
To
do
the
that?
right of that. Yeah, that one.
Or just plus.
And then just hit the plus on the zoom.
Yeah, I was just going to
Control.
go.
Control plus.
Yeah, control
Yeah.
plus plus.
Yeah, it's not going.
Control plus plus, does that work? I don't know, you're in, this is.
There you go.
Command.
Whoa. Oh,
Command.
Command, because it's out of a Mac.
That's, okay, fitting. Better?
Yeah, that's
Good, thank you.
All right, all right, good. Now I hope I can actually see all my real estate as I
Oh.
actually go through the demo, but we'll see. But anyway, this is MemSQL. Right? We're basically looking at 2 different nodes, these basically pieces of commodity hardware. They have nothing to do with each other. They don't know about each other from an AWS perspective. Commodity, shared nothing, pieces of hardware. These actually are running 4 cores. We basically monitor each core and see how much workload basically is going on to each core. We manage the amount of memory, the disk utilization, the network. All those things are critical for high performance, so we basically bring all of those out front so you can see exactly what's going on in your database. Right? We also allow you to see what's going on, right? With the database, I have 3 different tests, databases going on. One of those was a Spring database. You can see, the details of what's in your database. And you can actually see it's just, it's SQL data types, decimal, varchar, right? You can see create table, right? It's just SQL, but it's SQL in a creative way that's distributed across the board. So now what I'll do is I'll go into data sources, and I'm going to create a pipeline. And we'll go ahead and create our first pipeline. We'll just call this AWS. And we're going to point at a Kafka broker. Earlier, before the meeting, I got here early and set up a little Kafka broker, and I wrote a little Java app that basically is generating this JSON into this Kafka broker.
And random data generating.
It's not totally random.
Okay.
No, it's based on a truck route across the state of New York.
Oh, cool.
Okay, and you'll see the truck route as we get into Tableau. All right. It's a geospatial set of data on trucks traveling through the state of New York. So I stole it.
Cool.
But then I reuse it, right?
Hadoop is a way of generating random data too.
Yeah.
So, but
Yeah,
anyway, go on.
Yeah, this isn't random. This is basically just a data set. You can grab any data set that's out there and do, whatever, right? Just generate it and put it into base data. So we have Kafka, we have a broker. I only have one partition because it's just a very small little thing, but we look at like our Verizon things, right? We have 320 different Kafka partitions that we're doing, so it's massively parallel. And that's how we get this type of volume, massive parallelization. And our topic is called Gen Event, just generated events. We'll continue here. We have the ability to put a transformation, right? So in the middle of our pipeline, you can do ETL. Now it's row by row ETL. It's not group based, right? It's based because I'm getting this stream of data, right? Now I can enhance. So we have a lot of customers that do things like TensorFlow, right? And they will basically on this streaming data run a machine learning algorithm on that data, score that data on the fly that's coming in using our transformation. Right? Then they'll then push those scores down into the database.
And why won't do that with Kafka itself?
Speed, performance, right? The ability to bring in external data, other data, right, at very high speeds.
Well, Spark MLlib will do
Sure.
things quickly, but it doesn't have the capabilities that TensorFlow does.
Right, and so we allow you to do the same thing with Spark MLlib through Spark because we have a direct Spark connector, right? The problem with Spark, it's 100% in memory.
Right.
So now my data sets that I'm leveraging are terabytes and petabytes, right? And you can't, so Spark's great for a subset, right? But you just can't live with Spark as your model, right? You're perpetually trying to get the right data that you need into Spark to do the work.
So this is just some arbitrary executable that I can configure to run the transform?
Anything in a Linux world that takes a standard in and writes a standard out.
Okay.
So I write these things in Python, or Go, or Java, we usually discourage Java because Java has a lot of runtime overhead, right? So we prefer Reddit and C or something that is more performant. But basically it's a transformation, very basic, takes a standard in. We have a framework that tells you how to handle the standard in. Right? And then you basically have an array that you work with that's an array of the data you just ingested. Right? And it's all in a micro batch structure that you set how big that micro batch is based on your Kafka max offsets. Okay? So we'll just continue there. I'm going to now select the database, put it into my test database. I'm going to put it into a table called events.ext, which
And that already existed, your database.
Yes.
Got it.
It existed, and I had schema. Okay?
There's nothing wrong with it.
But people will tell me there's a lot wrong with it,
Well,
right?
I mean,
so I'll talk to them about how we built the schema, right? And why you want to add schema. And even though you're ingesting data today, you're always adding schema at some point in time to get value from your data, right? You have to add schema. We can ingest directly into a schemaless JSON structure. We do it all day long. But then you add schema later as you go. And then you're able to add indexes on top of schema and really drive high performance. So what I want to do here is actually show you the schema. So it's very simple. Again, it's just SQL. We have the first attribute being named data of type JSON. Right? The second attribute is MemSQL insert time, just so we're going to let that default to the current timestamp. But this attribute customer is a little bit unique, right? Because this is actually defined as a query of the attribute data. So we're going to query the JSON, right? And the colon basically says from here on, instead of SQL, execute JSON. And we're going to pull out this element called customer ID out of that JSON. And we're going to populate it in a text field in the database. Right, and we're going to do that for not just the customer ID, but an event and the generator and the latitude and latitude and all those kind of things. The reason I'm doing all of those is because my BI tools don't do JSON very well. Right? My BI tools do SQL. Tableau doesn't know about JSON. Right? So we extracted all these things out because these are the attributes we're going to use in Tableau to show you that now the graphics as the data streams in. And we said earlier we're going to let that insert time just default to the current date time. So we're only going to ingest data. Right? Really schemaless. We had to say, yes, I have a piece of JSON coming in called data.
You just busting the JSON up.
Sure.
So do you have any need for the JSON field after that?
I don't.
But not today.
Right.
Oh,
so
maybe someday.
and this is just a demo.
Okay.
Exactly right. This is just a demo. So I'm busting out all the fields, right? But normally I wouldn't, right? I may have 300 fields in here, and I'm only really normally pulling out the things I'm going to index, the things I'm going to join on, the things that I'm going to query a lot on, right? And then the other attributes, right, I'm going to allow basically the end users to write the SQL. Right? And so we've extended SQL, like you see here in the calculation, you see as data, right? That calculation. You can do that in your SQL and your select statements too, right? And my insert selects, right? I can do all kinds of things. So I don't have to keep all the JSON, but I want to, because it's what's going to happen in the future, right? All right. So now we'll continue. We'll go ahead and test my pipeline. Hopefully my Java app is, there we go, my Java app's running. Yay! And it's basically published into Kafka. And we pulled out this data. Here's just a first 10 rows that come out. And it's customer ID and event and generator ID and longitude and latitude and a timestamp. And we actually threw the timestamp away and used the, we let that default to the current timestamp of the database instead. Now we'll create the pipeline. It's created. See, Gary didn't jinx me. It's actually working.
I can fix that.
Yeah. I'll tell you, I did that to a guy the other day. He actually took my cluster and was using my cluster in a demo. But it was all internal, just with a bunch of sales engineers, right? And so I crashed, because it was my cluster, I crashed one of his nodes, right? But it was, I showed it, and I did it in order to prove our high availability solution. So in the middle of this demo, I crashed a node, and it just kept going. It kept going at a slower speed, because it only had half the processing power, but it just kept going. So here we're ingesting data. It's about 2,000 transactions per second going into this table.
So we saw things in progress and then succeeded, and those are the mini batches?
These are the micro batches, yeah. That are coming out of Kafka. And I didn't set the limit, so we're actually ingesting in micro batches as fast as my generator is creating them, which is a max out about between 3,000 and 4,000. That's all my generator will do. So we're limited here by my data generator.
If one is more used to Python dict instead of I understand it's the same as a JSON. Is there language for doing it in Python here? Or
so we would go through our transform.
I see. Okay.
Right, and push that.
Okay.
Because we don't have that as a standard data type. Right. So we would either push your Python dict into a JSON document,
which is the same.
right, or push it right down to attributes in the database.
But you'd have to serialize it somehow to
Yeah.
get it to here.
Yeah, exactly. There's some work to make that happen. Now we do, if you're using Spark, we have basically a Spark connector that does all the serialization for you. So you can basically just say data frame, populate MemSQL, and it'll just push right to MemSQL. Or you do the reverse, data frame, populate from MemSQL as your context. And it'll basically work that way. That's what Verizon uses a ton of that for us. Okay, so now I'm going to bring up just a simple SQL tool. It's not growing for me, but I'm going to do is click on my events.ext. I truncated it before we started. I'll click off and we'll click back on and it should send me, okay.
Yeah.
Since we tossed, we have 122,000 rows into that database. It's not allowing me to grow that one, but anyway, you can see here the first attribute is data, and you can see I've got the insert time, but you can see then I've got customer ID and event, and all those things are pulled out. And again, I can write any query, it's just SQL. I can write queries against this however I want, and I can point tools like Tableau against this. And here, since I brought up Tableau earlier, since I had no data, this is what Tableau looks like. I will refresh. Hopefully Tableau wakes up. There it goes, wakes up. And come on, Tableau. There we go. And now you can see, the data basically reporting in Tableau and streaming in, right? And Tableau is one of our partners, and so we do a lot with Tableau. But there are tools that refresh a lot faster than that for real-time dashboards. So you can see that continually going through. And you can see my geospatial events is that truck route across New York. I mapped in there. That's just where I got the data. So that
one truck sometimes had a low battery event rather than, I was thinking it was a fleet of trucks.
It is a fleet of trucks.
Okay.
It's a fleet of trucks, right, that are going across, right? And it's trucks that are tied to dealers, right? So you see this Albany, these dealers have different trucks, right? And so actually in my data, I don't have the dealership, right? I had a customer ID, so I'm joining to a dealership table, right? Things that are harder to do like in a Cassandra, but we're joining and putting that together. Right?
Looks like Buffalo is harder on trucks, or they don't maintain them.
I agree. Buffalo's a problematic dealer, and that's actually what you'd look at here. And the other thing is you can look and see, most of the events are normal. So you see normal is by far the,
Hey, maybe Buffalo just has more trucks.
Ah, it's not a fractional, it's a count then. Okay. I was thinking it was proportion. Okay.
It is just a count.
Okay, got it.
And that's because of my lazy SQL writing. I didn't do anything. But counts. I'm not a Tableau guy, so I just created what was easy to do. An account's an easy thing. So that's MemSQL. That's in AWS, but also on-prem and multi-cloud.
And licensing, costing, you have some information on that?
Yeah. Gary?
Yeah, again, it's, it's like anything else in IT, it depends. But it's all based on the amount of data that you use in memory. That's what we charge on.
Yeah.
For developers, we get it free for a few gigabytes.
Yeah, there's a free developer version.
Yep.
There's a developer, yes, you can go out to memsql.com and download the developer. Now, it's not allowed to be used in production, but it's a fully functional MemSQL, so you can run it across many nodes. It doesn't have, I say fully functional, and some things it's not fully functional, now that I say that. It doesn't have all the security, right, all your SSL, all that kind of stuff, right, are only in the enterprise edition. But it's great for a developer. You can, now, it is only Linux, right? So if you're going to run your laptop, you have to put it like in a Docker. There's a Docker container. You can just download a Docker container, run it right on your laptop. You got to have 4 cores at least. Got to have at least 8 gig of RAM. Otherwise, it's just going to sit, right? You won't get results. It's a great little thing to play with.
Yeah. But so that's running locally on when you said on my laptop, or it's an interface to When you said the developer version.
The developer version, you can run it wherever you'd like.
Oh, okay, got it.
Right? Most people run it in a VM or a Docker container.
Because they don't have Linux on their laptop?
Because they don't have
Is that-
Linux on their
oh,
laptop.
Wow.
Right. You have Linux?
Oh, yeah.
All right.
Naturally.
You can run it right in.
Yeah.
Yeah, good deal. Most of my people I work with have Windows laptops that we then have to
After
put
it's
it
there,
in.
it just creates more separation. So
Yeah.
Well, I have a dual
Yeah.
boot. Wow.
Any other comments, questions, anything we can do to?
So the price per gig or whatever it is, that's you paying? I don't know. I mean, we can look it up. It doesn't.
It's not
Actually,
published.
no. I'm sorry, these are the guys, their website says call for quote, and that
Oh.
always makes me very nervous. But-
Yeah. Yeah. You want?
So you can just.
Well,
I just as a
$200
theoretical-
per list is $200 a gigabyte.
Yeah.
List.
Yeah. Right, and if you're federal government, you don't pay that.
Half terabyte at least for us is going to be how much?
Yeah, so the ingestion thing, you demonstrated reading it from a Kafka topic and
Sure.
and that now automatically runs it as a parallel
That's right.
internally.
We match
We've
the
got
partitions.
multiple nodes that are reading it up, yeah.
Yeah, so if you have, 100 partitions in Kafka, and you would have a certain number of partitions, when you create your database, you tell it how many partitions you want.
Okay.
You usually want to align your partitions to your core counts, right? Because they're going to run in parallel, right?
Thread.
It's threads,
Threads,
right?
yeah,
Threads,
okay.
cores, partitions, right? So if I've got 100 partitions in Kafka and I only have 50 cores, I don't want to run at 50 partitions in MemSQL. I want to run at 50, and we'll just do two, sequential structures. But it'll match those up automatically. So you get massive parallelization. Also, if you're doing S3, right? If you're doing S3, we have, so I showed you Kafka, but we have S3 buckets. Same
Right, so you
pipeline
point
from
it at the
S3.
S3 bucket and it'll pick up.
And it just sucks it up, right? And so if you have a million files in S3, right, we're going to parallelize based on the number of partitions that we have.
Okay.
Right? We're going to basically, as soon as a partition is done with a file, it's going to go grab the next one in line.
So
from
if I'm
S3.
writing client code, so you said it's compatible with MySQL, for example. So if I'm
Yes.
writing client code to connect to the database and write to it for some sort of app that I have, then how do I manage that? Is it just one database?
It's a
server that's
database
visible
connection,
or- Yeah.
just like I'm connected here with SQL Pro or whatever. It's just like you would manage a piece of Java or a piece of Python.
I think we
It's
write
just
at
code.
one node and there is sync among the nodes.
That's
Yeah,
right.
so the-
Oh, I didn't go
I'm
through
just
all that
connecting
because there's
to
a whole
one
other
node.
architectural level that we didn't
Yeah.
even talk about.
Okay.
But you connect to a node called an aggregator.
Okay.
So normally you would have a load balancer across multiple aggregators. Right? And so you write a SQL statement, it goes to an aggregator. The aggregator then will rewrite your SQL and pass it down to all the partitions
Got it. Okay.
in the database.
Okay, so there's nothing special that I'd have to do as a client
No, you're writing
To-
SQL to
to-
the aggregator.
to exploit the parallelism capability.
No.
Okay.
And it automatically will expand out then?
No,
as
you have to tell it.
Tell it, okay.
Right, so today we have, we don't have auto scaling, right? So I think that's what you're asking, kind of, does it
Yeah.
automatically scale out? No.
You have to pay attention.
You have to,
That's nothing
right,
wrong
and so a
with
lot of
that.
our customers do auto scaling, but they basically have set scripts. They basically say, okay, at 70% utilization of RAM, I'm going to add 2 more nodes onto this, right? And then it'll just launch a CloudFormation template, right, to add those 2 more nodes.
But you're adding the 2 more nodes, then they fire up and they have their own EBS storage.
That's right.
So I can never scale down now because they're storing some
Oh,
of
I
the
can.
data.
So then I can scale down, right?
How
And
does
then
that happen?
it'll basically move that data from that EBS, from those nodes, to the existing nodes. So we will balance, right? We'll always spread the data over the existing nodes. So when you remove those nodes, you can't just shut them down. You have to wait. Because it has to take some time to get them back. Yeah, but you can scale out and scale back. Right.
I think the sequence has to be, we issue the command to MemSQL that we are get away from this node and then somewhere.
Yeah,
else
so that
it will
is
be.
right.
Yeah.
Is the Cassandra, how many replicas you are storing?
Only 2. Right, so we had the ability to do 3, And none of our customers used it because of resources and memory and all those types of things. So we are 2 nodes, 2 copies. In a high availability structure, basically, in my environment, I had two nodes, right? Where they basically are paired up to each other. And I have a master partition, right? On one node, it'll have a slave on the other node, in the other availability zone normally. I didn't do that on my little thing here, but that's normally what you would have. And then this one would have its masters, and it would have slave partitions on the other node, and they would basically back each other up. And that's how our high availability works.
Well, if you're using Spark, the default is 3 copies, and in memory. So I don't know how that, but that's different. That's
our
different
customers
than-
tell us that it's wasteful.
Yeah.
They're
okay.
wasting resources. They have to cut costs.
Yeah.
And so we built it in for a couple of our banking customers, and then they didn't use it.
Mhm.
And then nobody was using it. We said,
And then
why
you
are we
told them,
supporting
"We can
this?"
save you money.
So you don't support it anymore?
No. So we
I thought
support.
Cassandra and all, they had it configurable, right? You can do 1, 2, 3. something
Yeah,
like that.
yeah. So we were set at 2.
Start with 3.
Yeah, yeah. And there are, well, you can make it do 3. And you have to write scripts to do it.
I'm not saying it's necessary. You know,
Yeah,
and I
yeah.
don't-
You can make it do 3.
If
All the
nobody's using
commands are
it,
there.
there's a reason that
Yeah.
it's good enough, you know, I mean, it
Yeah.
works great.
Yeah, and that's what we see. All right. Any other comments, questions? Anything else?
Okay, thank you.
Thanks, great
Thank you.
question. Really appreciate it. Thank you.
Giveaways here, so help yourself if you didn't get anything. I don't know if there's any
I grabbed
pizza
the
or anything
shirt.
left, or-
There was some, but I put it in the fridge already.
I'll
Okay,
take the
no, no.
t-shirts, I
Scrap them,
guess.
I'm a little sad.
I said I will take the t-shirts.
Yeah.
Well, there's a jacket.
Thank you for coming,
Thank you.
especially
Thank
since
you.
it's so nice out, everybody that came.
Hey, well,
Yes,
this
thank
is
you.
definitely valuable.
Yeah.
I'm gonna check it out.
Is it really?
Because it seems so much easier than some of the, I mean.
Well, that's a lot.